helped get this here and has been instrumental and is also a SMPTE member. I'd like to introduce you to Gerald Donovan, who actually owns this wonderful establishment and who brought us all here. And Gerald is really, he is the town of Chesapeake Beach. So how many years were you mayor for?
25.
25 years. He was mayor before Bruce Wall was. So Gerald, thank you so much for hosting us here and having us here.
I want to thank all. I would just like to welcome everybody once again and thank you all for being here. You have no idea how important it is to our little town, our community, for this exposure. And can't thank you folks enough for being here, all of you. Thank you ever so much.
Yes.
Thank you.
Thank you. And you'll probably see him at the high top back there holding court if our friends from WJLA don't steal a seat again today. Where are you guys? That's all right, Ernie. And thank you all. So next up, you guys are here. Great. Jamie Duemo and Todd Gagorik from Amazon are here to talk about the fundamentals of cloud migrations. I'm really glad to have Amazon here. They're also a first-time sponsor this year, so thank you so much. When I have conversations with my customers and other people about moving to the cloud, and especially to Amazon and stuff, you start immediately talking about things in the cloud, and you start saying, well, you need these kind of EC2 instances and S3, and immediately they're like lost. They have no idea what you're talking about, and you realize there's this whole new lexicon that we need to know about cloud. And so I've invited Jamie, who, by the way, knows a lot about broadcasting, because for I don't know how many years you've been how long? 21 years been my go-to person for automation. So, so to have someone with her experience also in Amazon is phenomenal. And Todd, I'm going to get to know you better, but I don't know anything about you, unfortunately. But we will, but you're going to tell. And so I've also given them license to be talk a little more about Amazon itself and some things, just because I think it's really important that you understand the lexicon and terminology as you make these migrations of these infrastructures. And it's kind of hard to do that without actually talking about some of the specifics. So forgive me, but I wanted to make sure you understood all this. Thank you.
I assume this. It's still morning. Good morning. Yes, my name is Jamie Duemo. And in talking with Pete, right, just like he said, we're going to be talking about some vernacular and stuff when it comes to AWS, but a lot of the things that we're going to talk about from a fundamental standpoint is actually cloud agnostic, right? So it's just all about the process and a different way of thinking about the process with it. So what we'll do first is, and Todd and I are going to share this presentation mainly to shake it up, basically, right? So it's not always just a talking head up here. So we're going to first break down the buzzwords, right? So there's a lot of terminology and such, and it's like, what does it mean to me? How does it relate to my business today? So we're going to talk about that. We're going to talk about cloud-based migration strategies, so the patterns we've seen, the process, and the means of implementation. And then finally, because it is different, we're also going to talk about cloud-based pricing. So kind of give an overview of it, some of the methodologies with it, and then those resources that are provided to make sure you can cost optimize all along the way with that. All right, so let's break down those buzzwords. So first off, microservices. And I'm really doing this more from a level set, because I know for the fact I've been with AWS for about 1.5 years, and I didn't know a whole lot about this. So, so if anything, thank you for allowing me to learn more about the terms as well. But so microservices, it's both an architectural as well as an organizational approach to software development. Now, this is not necessarily a new concept, right? So this has actually been evolving in the software development space from a practice standpoint for a number of years. What it is a grouping of effective concepts and methodologies. And one of the things I definitely want to point out, because I'll refer back to this here in a little bit. And I know you've had a little bit of this throughout the presentations today as well. So I will apologize if we are being redundant, but I'll try to make sure to go a little bit deeper too, so this way it's not necessarily as redundant. But if you take an application service, right, and from a monolithic standpoint, this is where there are dependencies that are between the different services that are tightly coupled together, right? Where you have the fact for microservices is the ability to break out of that vertical stack and actually go horizontal instead. And therefore, it allows a number of different things when you're able to break down components like that. Number one, agility. Because you can actually get to, especially as a provider, a software developer, you can bring feature sets into the market really quick. Ease of deployment, again, because when you are deploying, instead of deploying a solid application, again, Pete talked to the fact I have years of automation experience. You know, it'd be one of the things where the applications were so tightly together that it was always a scenario when you go to put a feature in one part of it, you might break another. So this allows ease of deployment because you're only deploying that one microservice that is of interest. And finally, my favorite part is technological freedom. So this is the aspect where it's not a one-size-fits-all approach when it comes from the developers. So if a certain team finds a different set of tool sets is better for them in order to accomplish the goal, then that's fine. The one thing that enables microservices is the concept of decoupling, right? So let's hit on to the decoupling. Decoupling is building an architecture for complex workloads. So they're individual components, right? So we're driving off from the microservices aspect that are unaware of one another, right? So they just get up in the morning, they do their function, and they, you know, well, hopefully they don't sleep if you need that to be 24/7. But so again, it scales horizontally and not vertically. And so one of the main benefits, right, again, is the flexibility to scale. But another one is a minimized blast radius, right? So when you have components that aren't integrated together from a direct point-to-point, either from a just from a codifying standpoint, or just direct relationships, one fails, it's okay. So it allows for graceful failures. And here's an example, right? The concept of decoupling or loose coupled kind of technology, where you see from the top, a tight coupling is a procedural programming experience, where when you have a loose coupling, this is when you have individual phases. So if you have a failure with controller A, for example, the boat doesn't necessarily stop, and the other applications can continue on, at least to a certain degree. So now let's put this onto with a media lens. So let's give an example here. So I'm going to go back to my experience, right? So we talked about automation. So we'll talk about scheduling and BXF. So BXF, right, when it comes from schedules, is that you have a traffic system on one side, and you have an automation with a BXF reader on the other side. And one of the processes of the BXF reader is as the traffic system is publishing out over this connection, these BXF schedules, the BXF reader for the automation is reading it, validating the schema for it, and then it's converting it into its own language so that it can be appended onto its playlist. So this all works well until you have something where like a massive XML can show up. So a massive XML can show up, and let's say it's a 3-hour-long show with a lot of different secondary events. So it's a lot of information to process with it. Well, what can happen is that the BXF reader could get tied up with that process. And in the process of doing that, the rest of the schedules, the connection can get lost. Now, in order to recover for this, usually traffic systems work really well in the aspect of understanding that it never got an acknowledgement for the rest of the schedules that was sent. So when the automation reader can come back online, the connection is reestablished and it can republish. Or it's manual intervention in order to get the schedules back to an automation system. So from a decoupling approach, you have this scenario. You put a queue in the middle of it, right? And so if you have that issue where the automation system would have gotten tied up reading that schedule, traffic system's unaware of it. It doesn't matter. It keeps going to the fact and goes into the queue. And then the queue just waits for the fact for that connection to be made again with the automation system and can continue on. So one thing about microservices, and one other great thing about the aspect of decoupling is that it really is what the foundation for serverless computing, right? And this is very much a very cloud thing. So serverless computing, building and running applications without thinking about the actual servers. So you're separating out those services that those applications are providing and the servers themselves. So it's automatic provisioning and scaling and management of that. So some of the benefits: no server management, so zero administration. Someone talked earlier today about when it comes to costing and pricing, right? No cost if you're not computing, all right? So even for us, we have some services that we actually offer sub-second metering. Again, honed into the fact of only paying for that exact compute that you're using for. And then finally, high availability. So at least with the fact with AWS, that when you're using a serverless, one of our native services, you naturally get high availability. There is a backup somewhere else for you. So let's give an example of this. And I apologize, I'm going to keep doing this traffic thing, and traffic's not my background, but it just seemed to have played well. So we take serverless computing, and we put it to a media lens. So you have, let's go one step back from BXF and go back to drop folder strategy, right? So traffic system, you have a dedicated resource on the automation side that does the playlist translation. Now, that dedicated resource could be doing other stuff as well, but it's definitely there to constantly be scanning a folder, looking for an incoming schedule. Once it finds it, it translates it and puts it into a completed folder. Again, it's a dedicated resource. Now, a good example for serverless is you have the traffic system saying, hey, I got something for you. And only at that moment do you have a resource rolls up, your translator, and says, I'm here. And then the schedule will be sent, it'd be converted, and it'd be delivered to its final destination. The best part is, the last stop, is then the resource goes away. That's a perfect example when it comes to serverless computing. Some other services I just want to hit on because you're just going to see them in some of the other slides, because we're going to be showing some examples as well as some customer case studies as well. First off, when it comes from the media and broadcast side of it, our AWS Media Services are a good part of that with our live encoding, our file-based transcoding, packaging DRM, and ad insertion. The Amazon SQS, our queuing system, so that is, when I was making references to those queues that you saw, this is actually what I was speaking to. And then finally, AWS Lambda. So when we had that translator that popped up, did its work, run its code and go back down, that's Lambda. It's running code the moment you need it, and then it goes away. Yeah.
Just so I understand, so these are services that Amazon provides. They're not customer-provided software applications.
That's correct. So this is an example for serverless compute. So AWS native services are serverless. And so do that. So this is some of our examples within our ecosystem of.
Those exist.
Yeah, exactly, 100%. Yep, absolutely. It's all part of the toolkit, right? And then finally, and this was a great idea by Pete. We wanted to talk about just kind of bringing the terminology together between on-prem and in the cloud when possible. Again, so this way when having conversations, we're talking the same language. So if you were to do a play-out server comparison, Amazon Elastic Compute Cloud, or EC2, rolls off the tongue way better, is a good comparison for between on-prem and AWS terminology. If you want to talk about NFS comparison, Elastic File System, our EFS is the comparison with that. Archive would be Amazon Glacier, so we talk about cold storage. And this is a good one, I love this one. SMPTE traps and alarms comparison, right? So this is where Amazon CloudWatch, as well as Amazon's simple notification service comes into play. So CloudWatch does analysis of your ecosystem within AWS. It can track logs, metrics, and everything else. And if there's a problem, it can do something like kick off a notification service. That notification service can hit emails, texts, but it can also travel back to your operations center and set off an alarm on your monitoring wall. So that's why I was saying that's a really good comparison between the two. And then finally, online and nearline-ish comparison is Amazon's simple storage service. This one's a little bit hard because S3 is a little bit of its own definition, but this would probably be a close comparison with that. Now let's talk about cloud-based migration strategy. Now that we got all the buzzwords out of the ways, right? So I definitely want to hit on this. So what you see here is what we consider as 8 common key workloads at AWS. And so as we talk to customers on, about their traditional on-prem, they seem to kind of fall into these categories: acquisition, post, media supply chain, which there was a lot of good talks about earlier today, asset management, play out. And then, of course, the underlying on the bottom, analytics and AI ML, because it kind of touches across all the different workloads. And when I talk to customers and they want to take a look, they're like, we want to do a workload in the cloud, right? Like say play out. We want to do play out in the cloud. And what I often try to do is the challenge and say, look, you don't necessarily just want to look at one workload. Because when you look at one workload, you miss out on some other potential transformations that could happen that can make your system more automated, more efficient, and actually save more on costs. To just focus on one workload, just like when we were talking earlier about applications being monolithic or microservices, it's kind of a monolithic thought process of I just want to change this out. Because if you're going to have a cloud transformation, then you have, number one, the opportunity to remove the bolt-ons, both from an architecture as well as a workflow that has happened over the years. But the last thing you want to do is go into the cloud with one workload and now have to put other bolt-ons on some other part of it because you're only centering on that one part. So at this point, you're on.
Okay.
This one's
Am I up?
yours. You're up.
Super. Great. Well, before I get started, I'd like to first just thank you and say we're really honored to be here. As somebody who's had a lifelong love affair with film and television, just from a consumer perspective and dabbling in it amateurishly, the magic that makes it happen that you guys bring to the party is just part of the deal, and just a huge debt of gratitude for what you're able to make happen in this world. But when we start thinking about moving to the cloud, one of the core concepts and reasons that the cloud has such appeal and is just in an overwhelming growth phase is this notion of undifferentiated heavy lifting, of getting people, organizations, entities, workload managers out of the business of doing the things that aren't core to their mission, right? And enabling those scenarios to happen in a much easier and straightforward way so that really the focus can be on the mission of what you're trying to do, as opposed to all this other stuff that's well-trod roads of managing underlying infrastructure. Things like serverless computing and the ability to have, as Jamie alluded to, a complete back end that just executes code without you even thinking about, where's the server? Is the server up? How do I keep the server up? How do I make sure that it scales as I need it to? How do I make it go away when I don't want to use it so I don't have to pay for it? So all those things are very, very important. But when we start thinking about getting to the cloud, one of the tenets that Amazon embraces very much, and in fact, how many of you heard of the Fire TV phone or the Fire phone? How many of you bought one? Exactly. We're real big believers in failing and failing quickly, right? But that is a very important thing. We need to experiment. And what the cloud enables you to do in this environment enables you to do is to put things into it, try very quickly to see if it works. And it's very straightforward to make it happen. And if it fails, your cost is next to nothing, as opposed to building out an entire broadcast system, your footprint of all the equipment needed, all the capital investment. You don't have to do that. In the cloud, you just stand up pieces at a time and see what works and what doesn't. So experimentation is a very important part of it. The ability to apply metrics and look at the performance very, very rapidly and in very deep and insightful ways. We believe in relentless measurement at AWS and at Amazon and all up. We look at every piece of data that we can and tear it apart 1,000 ways. And the cloud gives you the ability to literally drill in and do that in a very straightforward way. And then the result of that is learning. As Jamie mentioned, there's often the fear of just stepping your foot into the water and trying, right? Well, in this environment, that fear is really very unfounded. It's very straightforward to turn things up, turn them on, play with them. Does this actually work? Does it live up to the claims that are being made, and make it happen? So when we start thinking about migration strategies, oops, I'm going the wrong way, aren't I? There you go. We want to get rid of all these time-consuming, expensive tasks. As I said earlier, this notion of undifferentiated heavy lifting. You know, at this point, we really know how to store data. We really know how to do it in a very highly available way. We know how to scale that, right? We do that 1 billion times a day globally for customers all over the world in every industry, right? It doesn't take somebody relearning that to manage that piece of it. So that's just one example. Removing complicated infrastructure that adds little business value. We want to take the complexity out of these business workloads and processes, right? And remove as much of that as we possibly can so that what's again left is the core functionality. And we think that's a really, really important point. Capacity planning. How many of you are familiar with this cycle? I'll try and describe it to you. You're responsible for acquisition of the hardware platforms that run in your studios or your edit facilities or whatever part of the pipeline we're talking about. Archiving, doesn't matter. You're responsible for acquisition of the equipment to make that happen. How do you guess or plan for capacity? How do you plan for growth? What if you're wrong? What if you're way more than right? In either one of those scenarios, it's very difficult to map capacity to demand in a good and accurate and consistent way. It's really hard, right? Sometimes it grows way faster than we thought it would. Sometimes it doesn't get anywhere near what we thought was going to be the utilization, right? So mapping the supply curve of capacity to the demand curve that's actual in a real world environment that is on premise is very difficult because, you know, you're not going to call up some server vendor and say, hey, I want to order 50 servers to support this workload. And then when you deploy it, you get it in 6 months later after it goes through the whole acquisition process and blah, blah, finally lands on loading dock. You get them racked and stacked, you get them put in, and then what happens? Oh, we turned it on and, well, crap, nobody's using this. Or we're not using anywhere near what we thought we did. Hey guys, can you take these servers back? We don't need them. Yeah, that doesn't happen. So what happened? You just wasted a lot. So basically getting out of that capacity planning. We have an example here of a workload. I think Jamie could probably talk to it more than I can, but specifically, Hotstar, Star TV, reduced both cost and time to market for its OTT platform. And we see this across the board. Somebody mentioned already Netflix, Amazon Video. These forward-leaning, forward-thinking platforms are able to scale and grow because of this approach to migration. I just blacked the screen. There we go. All right. So lowering the time to spend on infrastructure and concentrating on the new business initiatives, this is, again, that undifferentiated heavy lifting concept, gives you more time and more resources to spend on the actual innovation and moving the ball forward, right? There's a statistic that's been around in the IT space for many, many years that any given entity typically in a traditional IT world spends about 70 to 80% of their time just keeping the wheel turning, right? Just doing the stuff that's necessary to maintain. 20% of the time and budget and resources able to be actually focused on new initiatives or advancing the state of the art of where they are. And that's, we think, a very damning statistic. So migration to the cloud, make no mistake, we're not saying that you, when Jamie, I said, or mentioned the idea that you consider more than one workload, that doesn't mean that you literally take everything and throw it in the cloud instantly, right? It is an iterative process. But because of the nature of it, the nature of the environment, it is easy to fail rapidly and thereby learn and then say, okay, well, that didn't work. What about this? Oh, well, that didn't work. What about that? Oh, that worked. That's awesome. Okay, we're doing that. Let's go with that piece. And then we keep just attacking each piece of our workload and our pipeline. So the first step, obviously, is the business planning. What are the requirements? What do we really need to get done, right? What do we need to accomplish? From there, we do that analysis, and out of that comes looking at what we have today, what pieces are in place, what are candidates for lifting up and moving in one way or another, and there are many different approaches to doing this, moving to cloud-based pieces, right? And then designing the application and the infrastructure and that list of services that Jamie pointed out earlier, that's just an absolute fraction of the number of services that are available in the AWS environment, right? We have over 170 discrete services that are built for you to just use like Legos and just say, oh, we need transcoding services? Bam, yeah, we got that. Oh, we need video and image recognition that can actually derive deep metadata about every image and every object that's in that frame and distill that to some kind of actionable information. Oh, that's a chair. Oh, those are Mercedes-Benzes in that frame of the video. Oh, those are Caucasian people. Oh, those are funny-looking cats, right? And we can literally skin that out and say, look at that frame, get the metadata out of it, and now do something with it, right? That's a service that's just available. You just turn it on, you put your pipeline through it, and you get all that data out of it. You don't have to build it, you don't have to scale it. So there's a whole piece of design that you can just take off the table and say, I don't have to think about how it works, I just use it. It's a Lego block I drop in and put together. And then finally, operating it, migration and validation, getting it done, getting it put in place, and then finally operating it. And the operation piece becomes now much simpler. You have a 100% visibility and insight into everything that's running in your infrastructure in the cloud. And that's very difficult to say in an on-premise environment where things are changing constantly. We're constantly doing hardware refreshes. We're swapping stuff in. We're swapping stuff out. Bob's walking into the cable room and cross-connecting this router to this switch or this SDI terminal to this automation console, blah, blah, blah. All that happening. Operating in the cloud becomes a much simpler proposition in many ways. I mentioned there are a lot of different strategies for migrating. We start with the idea of lift and shift, and that's just the idea of taking exactly the architecture that you have on-prem and moving it into the cloud. Now, question, does that sound like the most effective way from a cost or leveraging of native services that are available to you to go? Yes? No? Everybody say, no, Todd, it's not, right? It is not, but it's very often where customers start, because it allows you to get the toe in the water with analogs, right? You get, Jamie went through some of them. This is like this. Oh, this is like this thing. This is like this. And once we get the analogs down, then we're able to move to the next step, which is how do I leverage that in the way that's native to the cloud? And that becomes a much different, and by the way, much more cost-effective value proposition. Replatforming, lift, tinker, and shift. That's what we're talking about, right? Beginning to understand, oh, I can do that with that. And now I just saved myself $10,000 a month, right? Because I'm doing it this way and leveraging the service. Repurchasing, just bang, kick that to the curb, do all new stuff in the cloud, right? Takes understanding now of what's actually there and available to be able to be used. Refactoring and re-architecting, it's literally now looking at new ways like serverless, leveraging those technologies that are more advanced. Applying artificial intelligence. I was listening to the question from the gentleman from the Library of Congress. Where is that fellow? James, where's James? I don't see him. Okay, James, he skipped out on us. Boy, I'll tell you, he's going to talk about his stuff.
He'll be back.
All right, anyway, yeah, he's actually stacking like tapes right now somewhere. But no, when James was talking about the problem that a long-term archival, workflow has, you can use things, somebody brought up, artificial intelligence, machine learning models. If that data is in the cloud and all that video stream and all that content is archived in the cloud, there can be processes running against it constantly that do that updating, that say, oh, every 6 months we're going to take this and retranscode it so the bits stay fresh, right? They do stay fresh in the cloud because of the architecture of the storage platform that underlies it. But regardless, we can do all of that, pipe streaming or workflow that maintains that content, keeps it in the new formats. All that stuff just happens automatically. We don't have to think about it as a human. Try that on-prem. Retiring, just get rid of. Some systems we just don't need. If we can leverage these new capabilities, we don't even need some of this stuff that we're doing now. And that's a great possibility as well. And then retaining, just keep what we need. We're under no illusion, for instance, that you're going to have right today acquisition of 8K video that streams up to your cloud, unless you have a 10 gigabit connections dedicated for it, right? That's one area where you're going to maintain, obviously, 8K cameras on premise. But what can we do after that in the pipeline, and where can we go? So those are conversations to be had. So common evolution of these strategies. It's all about abstraction. It's moving away from what we do down low, these low-level capabilities and functions, and saying, you know what, I don't need to think about that anymore. I can go a level up. Oh, well, now because I'm leveraging this service of serverless, I can go up again. And in every aspect of all these different things, Beanstalk, Dynamo, CloudFront for distribution of content, for OTT at the edge, right? Getting stuff out, streaming out to the internet. All those capabilities, those services exist in each one of these different silos, like application capabilities, persistence of storage and information, the networking functionality, getting it streamed out there, and the compute, all the things that you need to do to manipulate that information. So it's really about deploying as you like at your own pace, but now you're able to leverage again and again and again more and more value that's available to you in the cloud. So I'm going to turn it back to Jamie with that, and I'll be back to talk about cost in a bit.
So Script Networks Interactive is a really good use case study. All right, so when we talk about different migration strategies, and it was also mentioned earlier today as well, but it doesn't have to be all in, and there are plenty of times that doesn't make sense. So Scripps Networks, so they have currently today on-prem, they have a rendering farm, and they leverage ThinkBox Deadline for rendering purposes, right? And the problem they were having is that scale during their peak times. And their peak times is making the shows for Thanksgiving and Christmas, right? So all the cooking shows and everything else. So instead of building it on-prem, what they decided to do instead is leverage EC2 spot instances, and Todd will talk about that in a bit, but it's a great flexible financial model to go for. And especially when they realized that they used Deadline in the cloud, that they didn't have to pay an additional licensing, it came to the fact that they were able to elastically scale their environment for certain times of the year at a way more cost-effective rate than if they were to do it on-prem. So this one's a good story. But this one's actually one of my favorite ones. So Pop TV is a joint venture between CBS and Lionsgate. And they reach about 75 million households. Their production and post-production facility is out of LA. And they started running into scale problems as well. So for editing bays, they were running out of resources. They had no more real estate within the facility to build out new rooms. So one of the options, of course, would have been to go and rent facilities. But they weren't so keen about that for a couple of reasons. Number one, the whole aspect of kind of reconfiguring the room, but also moving the media over to them. So instead, they started working with one of our partners called Bebop Technologies, and Bebop was offering this concept of edit bays on demand. So they put that all in. The challenge they had with this project actually wasn't technology, it was people. Editors do have a great relationship with Glass. So they kind of like their process, like their rooms. So the leadership team actually went to who they knew was the most flexible editor that they had and said, go ahead, clients loaded onto your laptop, go home, go edit this, try to break it, finish your project, let us know how it goes. The editor went home and did it, he came back, and he's like, I spent more time trying to find a problem. All he needed to have was a broadband connection, and it Bebop leverages for this scenario was Adobe Premiere and Teradici. And it was such a great experience. So it became so popular that the editors started fighting for the edit bays on demand because they realized they didn't have to go through rush hour traffic in LA anymore to get to the post-production facility. So they count that successful. And now they're actually working on a content hub distribution strategy for DR as well as for remote review and approvals for the editorials and such. And if you want to see this story, so I left the link here, because I'm sure we're sharing presentations at some point. Go about 45 minutes into it, and you'll get to this part of the story. It's a really great story. So to allude to what Todd was saying, there's a few different ways, right, that you can build within the cloud, right? You can do native, which is with native services. You can use partners who have built on those native services, or you can use custom. Or for each one of your workloads, you can do a little bit, take a little buffet aspect, a little bit of native, a little bit of partner, and a little bit of custom. You can roll that all together. You have that freedom. So I know this is eye candy, but so if you were to build natively, right, and this is an example where you can find on Amazon Quick Starts, and basically you download a CloudFormation template and you can launch this in your AWS environment and just start tinkering around. But basically this is a video on demand for transcoding and distribution, both for Dash and HLS. So this is a great example of just building natively, going in, taking the different serverless compute models and creating an end-to-end workflow. However, that might not satisfy your requirements because you might not be at a point where you have the in-house talent just yet to actually create and build these toolkits into a workflow. Well, that's when you can actually leverage some of the partners that we have in our ecosystem. We have a growing number of media partners who present themselves to you in a few different ways, either as SaaS models, then that SaaS model can either be a managed service SaaS model, as well as a bring your own license. And what the partners do for you, like this example is SDVI, is that they build upon the AWS native services and create that workflow for you. So if you're unfamiliar with SDVI, they are a content ingest media supply chain orchestration. And so what they do is they create custom workflows based off of what your requirements are for files in to files out. And again, so they take the responsibility and the lift to build on the native services that have the benefits of what those are, and so that you can just launch and just go. Viset is another SaaS model, but it's a managed service. So Viset is a automation company, a playout company. It launched in AWS in 2014, 2015, right around that time. And again, so they actually, when they first launched, actually just did it in the cloud. So they started from the very beginning doing it with native services. And again, because of the requirements for high availability and scalability when it comes to playout. So that's a managed service SaaS model. And then finally, we have Evertz. I think everyone knows Evertz, right? Global broadcast manufacturer of solutions. I believe the next presentation will be about Discovery and Evertz. But yeah, back in 2015, Evertz started working with Discovery and with AWS. Evertz now is able to migrate and offer Mediator, their asset management system, and automation with as well as Overture, and place that into, develop that into the cloud. And again, because of the requirements of the high uptime and be able to control the diverse paths, they're also leveraging native services. So that's an option. And one of the things we always say when building, regardless how you build, whether it's with partners or you're doing it with yourself, that you do with a well-architected in mind. So this is actually available online, and it works for, again, it's cloud agnostic, but what it is that it's a prescriptive framework to be able to give guidance to people who are developing either in the cloud or our partners who are developing in the cloud, so that they are able to ensure security, reliability, and elasticity. So that's what we call as well-architected, right? So it hits onto these pillars here. Security, job number one. I think that literally is like, I think you actually have to put that on your application when you come into AWS is how serious you are about security. Reliability, build for failure, because guess what? One thing that always happens, failure, right? So we always put into the fact of building with reliability in mind. Performance and efficiency and cost optimization, because they kind of go hand in hand with it, because if you're not optimizing for costs or you're not being performant, you're also not being efficient, and you're not having what you can get out of from a cost optimization standpoint. And then finally, operational excellence. So that comes from the business side of it as well as from the people operational side. And now for the last part, we'll head on to cloud-based pricing.
Super. So the reason that we want to get out of undifferentiated heavy lifting is primarily driven by what? Agility, frankly, security, but very, very largely cost, right? And it's this cost model that the cloud brings to the party that is transformational. The people and the entities that have gone into the cloud have really very rapidly understood that what they used to do on premise is so much more expensive in terms of when you finally move cloud native and get all these services leveraged in the way that they're built to be leveraged, you can save significant money. You know, it's one thing to be able to scale up dynamically, which is one capability the cloud gives you. It is self-scaling. It understands that when a workload is increasing, I need more compute, I need more storage, I need better bandwidth, right? The cloud can allocate that automatically. And your cost only rises as your scale need rises. That's awesome, but what's even more awesome is the cloud recognizes that after the demand goes away and sort of tails off, you don't need all that anymore. So you double tap it and make it go away. It's gone. Just disappears or evaporates or reduces down to just the level needed to address the scale that's needed at the time, right? That is a massive cost advantage right there. In the cloud, we have different models that work for different services or different capabilities, but primarily it's a utility model. It's pay as you go, right? There are no long-term contracts. Now, there are some things we'll talk about in a minute that if you sign a longer-term contract, you will get better pricing for certain things that make sense, but in no sense are you ever locked in because your data always remains 100% your data, right? But this pay-as-you-go model is the rules of the road. You use what you use, buy the drink, you pay for what you use, and you don't pay for anything else, right? You pay less by using more, and that's where that longer-term contract goes in. There's tiered pricing models as you use more storage, as you use more networking, more streaming data, right? Your cost per bit or per byte or per gigabyte drops, right? So scaling utilization actually goes down. Save when you reserve. That's the long-term kind of longer-term contract, 1 year or 3 year terms to say, I know I'm going to have this base level of compute requirement. I'm going to pay for that up front. If you do that, you get pricing breaks to do that, right? Because we know that that commitment makes sense. And then spot options, we'll talk about that as well, where there's actually an entire market for resources that are third-party tradable. Think of it like the NASDAQ or the NYSE. People can actually bid on underutilized systems or capabilities in the environment and say, you know, if no one's using this, where it would normally cost me $2 an hour for this massive box, maybe because it's sitting around doing nothing, maybe Amazon's selling it right now or renting it or, you know, providing that capability to be used, making it available for 20 cents an hour, right? 1/10 the price of what it normally is. But it'll go away when you're not using it, right, potentially. And it can go away if somebody outbids you. So there are certain workloads where that makes total sense. We have scientific communities, for instance, that scale up to tens of thousands of systems in a matter of moments to render workloads, to do massive amounts of compute against a massive data set, right? And then they don't pay for that full price. They use spot pricing to do that. And so it doesn't matter. As stuff starts to go away, that's okay. The job just might take a little longer, but they're paying way less money for it. And then there's a lot of resources available to do cost optimization. The pay-as-you-go model allows you to, again, map your demand to your supply. We want to get you out of the business to the extent possible of massive capital expenditures, right? They're expensive. They take a lot of resource to just get things lined up. They're very coarse in terms of their granularity, in terms of capability to actually get it right. So we like to see you go away from that as much as possible, and in that departure, you will find a lot of savings. Pay for as long as you use. You just trade those upfront CapEx costs for variable costs. So we kind of talked about that, and you don't have to overcommit. When we think about all the different things, you know, up to 50 terabytes of storage is one pricing tier. 51 to 100 terabytes, more pricing tiers. Breaks across them. But 50 terabytes of storage for S3, which is, by the way, an object store. It's a HTTP GET POST, if you know what that means. It's basically you can either get a file or you can put a file, right? And that file can be anything from 1 byte up to 5 terabytes for a single file. What would be an example of a 5 terabyte file? A 4K video, exactly, that's 3 hours long or whatever. That's a 5 terabyte file. You put it up in S3. Guess what that costs you in Amazon? 0.023 cents per gigabyte. Go buy a SAN for that. Anywhere close, right? And if you keep scaling this up, it even gets less expensive. And we could spend days talking about all the different nearline and hierarchical storage tiers that we have available, all the way through to things called Glacier that are fractions of that cost for long-term archiving, which then we can, again, run AI against for the Library of Congress Fellow to do all that metadata processing, right? Save when you reserve. This is what I was talking about, these longer-term contracts. We have what are called reserve instances of compute capability. If you know, again, your workload's going to be this long, I can save it. I can say, I want to buy that up front because I know I'm going to need it, right? It's not something I want to scale to 0. I want to scale to 2 boxes or whatever, right? I want to buy those up front, save money. Spot, I talked about, it's just flexibility. Certain workloads make tons of sense for the spot market. You can just grab them at a price, bid on it, say, I'll pay that. As soon as somebody else says, I'll pay more, you don't get any more of those spot instances. And as they shut down, they go away, and you have to bid more for them. That's the market piece. But The reality is most of the time you can get a lot of your compute done using Spot and being good with it. Again, this is just a graphic that kind of points it out, but using reserved instances where it makes sense, but then when I need to burst for some kind of processing job or workload, like a rendering farm, right? I can say I want to render this, and where time is not the constraint necessarily, right, but cost is, I want to apply a budget of $200,000 to this render job. It could take a day, it could take a month, right? And if you're okay with that, boom, that's an example of one workload where it would work out. And then optimization. It's funny, this is the only company I've ever worked for, and I spent a long time at another very large IT software company. You'd know it. This is the only company I've ever worked for where we actively try and lower your bill as much as possible every month, right? We work hard and we give you tools to identify opportunities for cost optimization. Because just like all of Amazon.com, delighting customers is really what's at the core of our mission. We want your customers, you, to be happy with what we provide. So we give you calculators, we give you a total cost of ownership calculator, and monthly calculators to literally model out what does the architecture look like, what are all these different components that we've talked about, how do they work together, boom, drop those in, say, well, this is what I think maybe my scale will be, and out will pop a number and say, this is your monthly bill. No commitment, no nothing, you just turn it on, run it, and that's where it's gonna be. Yep, so with that, I'm gonna ask Jamie to come back up, and happy to take questions. If anyone has any. Yes?
So while you're Amazon focused, you didn't talk at all about cloud interoperability. So there's more than one cloud, I think we all know. And
There is?
if you're going best of breed, and while you guys might be 1, 2, and 3 in the stack, there's 4, 5, and 6. And what about interoperability between clouds if I want to do microservices across multiple clouds?
Okay.
See what I did there?
Sure. So yeah, we get this question all the time across industries, and I'd say there's 2 or 3 answers to it. First, I'll start with the biggest one. We find a lot of entities go down the road of the multi-cloud strategy and put that out there and say, well, we're going to adopt the multi-cloud strategy. When you adopt a multi-cloud strategy, understand that what you're trading off is the flexibility of deeply leveraging that cloud provider's service catalog, right, in a native way versus trading that off for least common denominator functionality. Right?
Regardless of which cloud, right?
Regardless of which
Doesn't
cloud.
matter.
Doesn't matter. If you go down the Microsoft cloud, the IBM cloud, the AWS cloud, it doesn't matter. There's capabilities that exist in those clouds that can only be leveraged in a way that's deeply integrated by leveraging that cloud. That being said, there's plenty of mechanisms for allowing inter-cloud or multi-cloud interoperability. Again, your data is your data, and you can expose, for instance, storage platforms and EC2 instances, compute capability, and all that stuff through many different mechanisms, API gateways, just exposing the data via S3 for calls and puts and gets from that kind of thing, to have other clouds grab that data, process it, send it back and forth. There's, again, though, an intrinsic problem. We talk about something called data gravity. Data has gravity, and especially in your world where your data is massive because it's high-resolution video typically, that data, moving it around is hard. It's very hard. And so when you think about, okay, what are my advantages versus the trade-offs, you can get out of our cloud anytime you want to. Again, we don't lock you in. All that data remains yours. But cloud interoperability, while possible at a least common denominator way, absolutely, is not something that can be said in the same sentence as full and rich optimization. That's why you see the most sophisticated customers that we have are 100% native on us, because they're leveraging. I'll just use Netflix as always the example. I know people get sick of it, but those guys leverage every service that we have. They know it better than we do, and practically. And they really have tuned the living daylights out of every aspect of their operation and pipeline by doing that. I saw you shake your head, though. Like,
Sorry about that, Rick. I'm sure everybody in the room does monolithic vendors and only go with one vendor for everything. Everybody that does that, raise their hand.
right.
Right. So all you're doing is preaching monolithic vendor because you
So I get where you're going, and I don't mean to suggest that we have everything. We don't. And I absolutely, again, in that statement, you can expose the data that's in the AWS cloud, the operations that you do in the AWS cloud to any other cloud. And there are many, many, many different integration links that are possible. Where it makes sense, you can do it, right? Absolutely. So happy to take that offline and discuss it more, but you absolutely can create interoperable environments where it makes sense. But you tell me if it makes sense if you have 600 petabytes of video in one cloud, how you're going to move that around, the whole thing, to do, say, well, we want to put it in AWS because your storage platform's cheaper, but Microsoft has a better AI, or IBM has a better AI environment with Watson. So somehow we're going to take the AI over there and hook it up to the data that's over here. I hope you have a very deep pocket for your network pipes, put it that way. But anyway, next question. Yeah. Oh, sorry.
Yeah, just right here.
Yes.
Now, and I think this kind of touched on my question as a consultant.
Mm-hmm.
How are you dealing with change management with this? Jamie, one of the statements you made was you attempt to challenge your customers to focus on the total workflow. With, I think that was Gary's voice I heard back there kind of talking about. And then one of the things you were saying was getting people to stop doing things that are not core to the mission. Now, as consultants, we know there's a lot of stuff in there, and as I always say, everybody wants change until it comes. How are you working with that, with this in-depth tool set you have, and the kind of things you're facing, with the last question you had?
So I'll start with it, and this is available online, and this might be of interest. So we have this another framework. It's called the Cloud Adoption Framework. And a part of that is basically we've taken, when it talks about migrations and stuff, because you're right, it's not just technology. This is a people transformation, and no one's talking about that in depth. And I'd like actually just to start talking about that and those tools that are available and such to start elevating, people's roles in what their skill sets are, right, for like this new world, right? So Cloud Adoption Framework has. Oh goodness, is it 8 pillars? But one of it is that it addresses a lot. It gives a prescriptive model on how you can start addressing and making work streams that are based off of not only the technology or their platform standpoint, but also the people and the business standpoint to it, right? Because it's a bit different from a finance standpoint. So there's actually a lot of learning that has to go with how do I now do my forecasting? How do I now, do our normal accounting we've always done and do it in a variable model? Also, when it comes to like HR, like how do we now like rework a strategy to assist the current staff in getting their skill sets? How do we reward them and everything else? So the Cloud Adoption Framework is a really good model. We actually use it too. So anytime we're starting migration processes with that, and do it up front, because when you're doing the migration planning, where you saw the business portion of it, that's a perfect opportunity to actually now kind of itemize with the customer who fits where in these and start addressing, because that part's a journey as well.
And to add that, just a couple things. One of the things that is absolutely core to that migration is, yes, governance, right? Putting into place how we're going to do that, each stepwise process to get from where we are today to finally into wherever we've determined our direction is desired direction or desired outcome is. There's governance models around all of that. The Cloud Adoption Framework addresses some of that, and there's a lot of other resources that we can bring to bear on that, but that's a very important part of it. There was another question, I believe. Yes.
So Todd, it's great that the ingress is free. It's great that the storage is cheap and processing is cheap and adaptable. So I can put my files up there, I can store them, I can process them, I can do all sorts of great things with them. If all I need back is a couple of little bits of data from it, that's great. But we're in the media industry, as you pointed out, we've got huge files, we've got huge streams. What is AWS doing to address the egress costs to make it work for media and entertainment for us? If I'm not getting paid for every byte that I deliver to a Netflix client, if I want my data back after processing, it costs me too much. What's AWS going to do about that cost model?
So there's a few different strategies where I would start down the road to answer that question. The first is architecture. So one of the services that you may have saw up there that was put up was something called CloudFront, and there, depending on how you architect your AWS environment to basically stream that data back out and allow access to it, there can be significant cost savings realized by doing it the right way versus doing it the wrong way. The wrong way, for instance, is just putting a pointer to an object on S3 and let your player point to the S3 bucket and grab it, right? Not effective, right? Because CloudFront essentially is a caching mechanism that can be distributed around the world at a much reduced cost from someone retrieving data directly from S3. So there's architectural discussions that come into play first. Beyond that, then it becomes monetization strategies around what is your budget, what is your consumer base, what is the amount of bandwidth that you're pushing out there in your streams, how much of that activity is occurring, how do you monetize that? That's more of a business conversation, but it's absolutely one that is worthy to be had. And there's a lot of strategies that we've seen a ton of customers in this space utilize to monetize their content in ways that aren't, on the face of it, something that they would just obviously think of. So that's another aspect of it. Sorry, it looks like.
Yeah.
Okay, sorry.
Yeah.
Okay, cool. I don't want to step into the next person's time.
So let's say I do have all of my content on, say, Microsoft Cloud Storage, but I really like your AI analysis, and I don't want to move massive files between them. Can I take your native, software services and install them on non-Amazon servers?
You absolutely cannot.
No. But just to hit on that though, right? So if you use an example of like, you talk about AI/ML, right? So when it comes to machine learning, we incorporate a number of different strategy and models with it, and one of it is it was TensorFlow, Caffe Torch, MXNet. So you can look at the fact, at least from a modeling, that you can actually stand up a model within AWS, and that is something you could capture and go stand up somewhere else from a compute standpoint. So
model itself.
The model itself that you're using. So therefore, taking the tools, if you will, and making your own model, that can go anywhere. Mm-hmm. So again, it depends. Native services, no. Just like Microsoft's native services, yeah, you can't pull it over here either. But there are other things. There are part of it to kind of break down that if we show you underneath the hood, that can go. Mm-hmm.
I can stay till like probably 3 o'clock. That works.
Okay, so I was happy to hear that you're all about delighting your customers, but hybrid clouds are a big part of that delight. Mm-hmm. And I'm not quite sure that Amazon understands completely the needs of many customers, which are just point-to-point instead of point-to-multipoint. Mm-hmm. CloudFront is good at reducing costs and point-to-multipoint, geographic distribution, that sort of thing. But a lot of our customers really need to pull things point-to-point. In the hybrid cloud, there are solutions. There is cheaper storage out there than Glacier. It's not as diverse, but that's attractive to some customers. There are all the customers don't have to put the full resolution video in a single cloud. They can put the full resolution video where it's cheapest to store it. They can put the proxies that need to be available to AI enrichment and other things in other areas where it's cheaper to process them there. Mm-hmm. So there are very real reasons to do hybrid clouds, and it would be nice to see some acknowledgement that we need some delight in that area.
Yeah, so again, there's nothing, we would not suggest that there's anything prohibiting you from being able to leverage the services that make sense in the places that you choose to leverage them, to include on-prem, by the way. We have a deep and far-reaching partnership, for instance, with the #1 virtualization vendor, which is VMware, to essentially, which I'm sure many of you run VMware infrastructures internally, to basically do complete integration with the AWS set of cloud services and your on-premise set of VMware resources, right, for instance. So we get the whole hybrid cloud perspective of I've got on-prem capabilities, I want some of it in the cloud, and again, tying up the interoperability between different resources, yes, absolutely. If you want to put the bulk of your data one place, but you're able to derive metadata from that, then there's lightweight to ship over to another cloud provider. It's just like the machine model export, right? We use a bunch of different frameworks for that. So those things are all possible and not something that we would all, rail against. You can absolutely do it. And we want to delight our customers in that way and enable you to do that where it makes sense. Again, it's just what makes sense, and that's the conversation to have. Getting to the right combination of services where it makes sense.
First of all, kudos to you guys for taking such a leadership role and bringing cloud to us and such a great suite of cloud technologies. It's awesome what you guys have done over the last 10 years or so. My question specifically on the broadcast arena, what are you guys doing in terms of bringing in live streams, live feeds, contribution feeds over dedicated networks? And on the distribution side, going over multicast-enabled MPLS networks, for example, switching from live to live with sort of frame-accurate switching or live to file and back and forth at the top of the hour. What are you guys doing in that arena? Most of what you're doing is file-based. It's lovely. What are you doing on the live side?
So yeah, so I'll hit on that. So right, so what you also want to imagine with AWS, we have a bunch of our own services, and we have a lot where we leverage partners, right, to fulfill different workloads. So I can actually give you an example. Visset was one company I saw earlier. They're doing that now, right, live play out in the cloud. They do it with Jinx, which is an esports gaming. I believe Sky and ITV is a joint venture with that. And so what they're doing, they're actually doing it over public internet. So they're not even doing it from a direct connect standpoint, from a managed network. And they take multiple feeds from a variety of different, either their production facility or at other different sites, venues for e-gaming. Not the expert on the e-gaming part. And they sing it into the cloud, right? And so there's the fact is they're using Zixi, one of our partners, for that onboarding process. It's going through Visset. Visset's the ones managing it with scheduling and operations, the switch between that and their interstitial content, because I don't believe it's commercialized on that one. And then from a distribution standpoint, in that model, it's actually doing public internet again with Zixi to the uplink facility for the final StatMux and uplinking there. We also have a lot of other customers who are playing around in the space of actually doing as much distribution as possible in the cloud. So still live, but just to go down the workflow path a little bit, right? A one-to-many. And actually starting to talk to their MVPDs to say, come and get it. We'll send it to the fact of colo locations where it can be terminated from a direct connect and you all can get there. Else, the rest of you can get it over public internet and make sure you have this much bandwidth available to it. So therefore, doing a one-to-many, not an OTT model in a traditional TV model. So that's another thing that I've actually been personally working on with a few customers over the past 7 months.
Todd, Jamie, thank you so much. That was fantastic.
Thank you.
We'll take more questions later.